viewers, welcome to Pocket Science channel. இது உங்களுக்கு ஹெல்ப்ஃபுல்லாக இருந்தால் லைக் பண்ணுங்கள், சப்ஸ்கிரைப் பண்ணி சப்போர்ட் பண்ணுங்கள். கமெண்ட் பாக்ஸில் உங்கள் டவுட்ஸை கூட நீங்கள் கேட்கலாம். பெல் பட்டனை ப்ரெஸ் பண்ணி அப்பப்போ புது வீடியோஸோட நோட்டிஃபிகேஷனை கூட நீங்கள் பெறலாம். தேங்க்யூ ஸோ மச் ஃபார் வாட்சிங்.
Hello guys, welcome to our next video. Today also we'll be talking about 2019 past paper MCQ from 11th to 20th questions. And if you feel useful, please subscribe our video Pocket Science and keep in touch with us. And today guys, I'm going to tell you some little techniques to how to approach MCQ questions as well. And these little techniques will really helpful for you to manage your time in the exam paper. The 11th question of this paper: consider the following statement made regarding the velocity of sound in Earth atmosphere. A. It does not change with altitude at constant temperature. B. It always increases with decreasing pressure. C. It decreases with increasing altitude as a result of decreasing temperature. So guys, in these type of statement questions, we always start from the final statement, because normally these kind of MCQ questions, the right answer will be in 4th or 5th, because it little bit concede times for you to read all the first 3 and come to the last one. So in these kind of statement questions, we will be looking from the final one, right? So we'll see at C, it decreases with increasing altitude as a result of decreasing temperature, right? For this, we'll little bit go into the theory and look after what the theory says first. We'll just look out how the pressure and density changes with the increase of altitude, right? For this, I'm going to draw a small graph, right, with altitude, right? We'll consider pressure and also density. So this is how the pressure changes, right? And also density, if you have a close look, density will change like this, right? So with the altitude, the pressure and density are going to change like this, right? So you can see both are changing in slightly same manner, right? Due to the change are equal, the fraction P over rho will be a constant, right? This is a first statement, or the first assumption we are taking. P over rho will be a constant. So the equation for velocity, we know that it is V equals root Pt over the density. Okay, so here, as we already said, P over rho will be a constant, right? So the velocity depends only in temperature. Okay, so the velocity depends only in temperature. Now we know that the velocity is not dependent on pressure or density, but the velocity only depends on the temperature, right? So now we are coming to the statements. It decreases with increasing altitude as a result of decreasing temperature, right? They have said that with the decreasing of the temperature, the velocity decreases, right? That's correct. So C is a correct statement, right? Now look at the answers. First one says only A, but we know that C is correct, so that will not be an answer, right? And also look at the second answer. It says only B is correct, so that's also a wrong answer, right? And then we have only C. We'll keep that it for a while. And also the other two answers also consist C, so we'll keep those 3. And first 2 answers are not correct answers. The statement B says it always increases with decreasing pressure, right? So now we proved that velocity only depends on the temperature, so that statement is wrong, right? Now coming for the remaining 3 answers, the 4th answer has A and C, right? And also the 5th answer has A, B and C. So we proved that B is a wrong answer, so 5th and also a wrong answer. So however, we have 2 remaining, so we have to look at the A statement. It says it does not change with altitude at a constant temperature, right? We know that at a constant temperature the velocity doesn't change. So statement A also correct, so the answer will be 4th one, right? Next question: which of the following statement regarding the X-ray production in common application is incorrect, right? So we'll go from the 5th answer. X-ray tube must be evacuated to avoid the energy loss of electrons. That's correct, guys, because if the X-ray go and hit some air particles, with the collision it may lose some energy. So to prevent the energy loss, it should be evacuated, right? So the fourth one, the energy of the X-rays emitted depends on the current through the filament. So that one will be the wrong one, because the energy of the X-rays depend on the voltage across. It doesn't depend on the current, right? The intensity depends on current, but the energy depends on voltage, right? So that statement will be a wrong one. So the answer will be 4. So you can look at the first three if you want. Two circuits are used in X-ray production system that you already know. So anode could be damaged due to the bombardment of the electron, because electron does have a mass, so if it goes and collides, the anode could be damaged. And also low voltage is sufficient to heat the cathode, right? That is also correct. You can heat the cathode with a low voltage. So fourth one will be the wrong statement. So that's the correct answer for this question. 13th question. Consider the following statements regarding the dew point of the air having water vapor in a closed container, right? So C statements, at dew point, if the volume of the container is reduced, the absolute humidity of the air will increase, right? That is the wrong one, guys, because if a container is in a dew point, it is at the highest humidity for that temperature, right? So if you decrease the temperature, what happens is some amount of vapor will be condensed, right? Some amount of vapor will be condensed and make water in the container, right? And the humidity will remain unchanged. C is a wrong answer. So fifth one is not possible, and also fourth one is not possible, right? So we have three answers remaining. So checking the B statement, if the temperature is reduced below the dew point, some of the vapor will condense, right? That is correct, because you know that if you decrease the temperature below the dew point, there will be condensation. So answer A is not possible, right? In this question you will have to look at the A statements also, but in some questions by looking only two statements you can omit the wrong answers and you can go for the correct answer. So that did not work in this question, but that will help you in some other questions which you can omit all the four answers and go for the correct answer by just looking at two statements. But in this question we will have to go for the A statements as well. At dew point, unsaturated water vapor becomes saturated water vapor, right? That is correct. The dew point is where all containers fill with the maximum amount of water vapor that could resist, right? That's why when you reduce the temperature below the dew point, you will see vapor condensing. So at dew point, the vapor is saturated, right? Before the dew point, the vapor is unsaturated. So at the dew point, the unsaturated water vapor becomes saturated water vapor. So statement A also correct. So the right answer will be third one. 14th, when the tension of a wire is slowly increased from T1 to T2 with the proportional limit, its length changes from L1 to L2. The energy stored in the wire during this process, right? For these kind of questions, guys, it's better to go with graphs, right? That is the main technique you should know. In these kind of questions, it's better to go with the graphs. Okay, you know that energy stored in the wire will be equal to the work done, right? You know that work done is the energy change. So as an example, when there is a spring, here it is at energy level 0, right? When you push it inside, due to the work you have done, right, there will be an energy stored, right? So when you release it, that energy will work as a kinetic energy to push back the spring, right? The same thing is going to happen in this wire as well. So we can find the energy saved by the work done, right? So I'm going to the graph F versus L graph. So they have said that at T1 the length is L1, right? At T2 the length is L2, right? So there is a increase. So the energy saved can be obtained by the area under this graph, right? So you can directly find the area. So the energy saved will be half into T1 plus T2 L2 minus L1. So this will be the answer. To obtain this answer, they have said that the main assumption is this should be in the proportional limit, right? You know that the stress strain graph, right, it is proportional or it is the elastic state at this position, then it is going to the plastic state and ultimately it will be fractured, right? So this is the proportional limit, right? This is the proportional limit until it gets yield, right? Until it gets yield, it is in the proportional limit, which means it is in the elastic limit, which means if you extend a wire and you release it, it will come to the initial state. So that is the main assumption we are taking in these questions. So considering that, we can write the energy saved by this equation. So the answer will be fifth one. 15th, hydrogen gas in a container is maintained at standard temperature 300 Kelvin and pressure 1 into 10 to the power 5th Newton meter minus 2. If the root mean squared speed of hydrogen molecule is 2 km per second, what is the density of hydrogen in the container, right? So this is directly from the ideal gases and will be directly going into the equations. You know that the equation that is directly depending on the pressure and the root mean speed is P equal 1/3 density into 2 square bar. Okay, so this is the equation. So we will be directly substituting into this equation and you will directly get the answer for the density. So you take density out. So it will be 3P over C2 bar, and if you substitute, you should consider that the data is given in kilometer per second. So we should change that into meter per second. So we should add 1000 and it will be meter second minus 1. Right? So the answer will be 0.075 kilogram meter minus 3. Right? So that will give you the second answer as the correct one. 16th question says, a composite rod is formed by connecting two rods A and B as shown in the figure. Longitudinal wave velocity in rod A and B are 3210 meter per second and 6420 meter per second respectively. A longitudinal pulse applied at the free end of the rod A propagate with the wavelength of 2 meters. What is the wavelength of the wave when it propagates through rod B? Right. So this is what they are saying. As a rod, here it's A and here it's B. It's two type of different rods, right? The velocity here is 3210 meter second minus 1, and here the velocity is 6420 meter second minus 1, right? So this is directly double of this one, right? So you know that the velocity changes, right? According to the velocity, the wavelength also changes, right? The velocity changes, the wavelength changes. So the equation V equals F lambda, velocity changes, lambda, the wavelength changes, only the frequency is equivalent for both the rods, right? So what we are going to do is, you are going to equalize the two frequencies of the rods, right? So it will be F1 equals F2, right? So you know that if you take F out here, F will be V over lambda, right? So I'm going to substitute here, right? So F1, V1 over lambda 1, V1 we know that 3210 over wavelength they have said it is 2 meters, right? Is equal to, here the speed is 6420 and the wavelength we should find, right? So you know that this is double of this one, so you can directly cut that off and you will get 2 here. So lambda, the lambda 2 in the rod 2 of the not that B will be 4 meters, right? So lambda 2 is 4 meters, so you will get the answer fourth one. The next question, the magnitude and the direction of the electric field at point A due to the point charge distribution as shown in the figure are, right? So I'm going to draw the figure first. So this is the distribution. So if you look closely, you will recognize that this is the easiest question of the paper, because the field that this charge creates and the field this charge creates will be equivalent in opposite direction. So those two will cancel off. So there will no any electric field due to these two point charges at A, right? So the field this creates and the field this creates are equal and opposite. Also the field this charge creates and the field this charge creates are opposite and equal, right? So the only field that is acting in A will be due to the resultant of plus q and this minus q, right? So this will be in this direction, right? And also this will be in this direction, because since it is a minus charge, it should be into the charge. Since this is the plus charge, it should be coming from the plus q charge, right? So these two will go through A. So the resultant electric field will be coming from this plus q and this minus q. So you know that the electric field equation is q over 4 pi epsilon naught, and this distance is a, so it is a square, right? And also here electric field is same, but since we have marked the direction, we should not include the minus, so I can directly write q over 4 pi epsilon naught into a square, this length also a, right? So why I have not included the minus here is I have already marked the direction, so for this direction it will be plus, right? So you can see both are in plus, so when you add this you will get a double of this, right? So the answer will be the first one, 2q over 4 pi epsilon naught a square, and the direction is in this way. 19th question. When a current 6 ampere is flowing through a primary coil of an ideal transformer having power of 60 watt, output voltage is 12 volts. Select the correct answer which gives the type of the transformer and the current ratio, right? The primary current into secondary current ratio, right? So here there's a primary coil and there's a secondary coil. We don't know the ratio of the coil amount, right? So what they are saying is 60 watt is transferred in these coils, right? The main assumption that they have said is this is an ideal transformer, right? Which means there is no any power loss between the primary and secondary coils. So here also you have 60 watts and here also you have 60 watts. And also they are saying the output voltage is 12 volts, right? And the input current is 6 amperes. Okay, so what we have to find is, here there's a voltage of V, we will assume, and here we have a current of I, right? Okay, so what I'm going to do is, you know that power is equals to voltage into current, right? So I'm going to write the equation. The power is 60 watt, right, is equals to, here we have the voltage V and the current 6 amps, right? And also if I write the equation in the same line for this part also, the 60 watt will be equals to 12 volts into the current through that coil, right? So I take these two and simplify, and I can get the answer for V. V will be 60 divided by 6, 10 volts, right? And also the current here, I'm going to simplify these two parts, right, as the same equation. 60 divided by 12 will be, I is going to be equals to 5 amps, right? So you get the answer, V is 10, and you will get the ratio I1 into I2 will be 6 into 5, right? And also you know that here it is 10 volts, here it is 12 volts, the voltage is increased, so it will be a step up transformer since there is a voltage increase, right? So this is a step up transformer and the ratio of the current is 6 into 5. So the answer is going to be the fifth answer. Last question of the video. A coil is made by winding n number of turns into a plastic ring of a mean radius r and the cross section area A as shown in the figure. This coil is placed coaxially with a long straight wire carrying a current of I. If the rate of change of current through the straight wire is I cos omega t, which of the following expression gives the electromotive force induced in the coil? Ring, a plastic ring winded with n number of turns, right? And a wire is going through it and it carries a current of I, right? And the change in current is, which means delta I over delta t, right? The current change ratio they are saying is I cos omega t, right? So they are saying that the radius, the mean radius is r. So the density that creates in this r distance, we can write it as B equals mu naught, the current I, over 2 phi r. Also we can write the magnetic flux through the coil. Phi is equals to VAN, right? So we can substitute B here, so it will get mu naught I AN over 2 phi R. Here the main idea is the induced EMF, right? The induced EMF is going to be equal to the rate of change of the magnetic flux, right? So it will be delta phi over delta T. Okay, so that's the main idea. So hereafter you can do the question by your own, right? I'm going to substitute delta phi here, so it will be to delta mu naught IAN over 2 phi R to delta T. And you know that mu naught is a constant, A and N also constant in this question, and also 2 phi R constant, so I can take that those things out from the delta, so I'll get mu naught AN delta I, that's going to change in this question, 2 phi R into delta T. For this part, I can substitute I cos omega T. So the answer will be, I am going to write the answer over this side, right? Over this side, mu naught AN over 2 phi R. For this part, I am going to substitute I cos omega T. Okay, so check the answers. The answer is 4th. So guys, that's it for this video.